background, I did farm for 10 years here in Pennsylvania. I'm coming to you from Pennsylvania today. And I had an organic vegetable operation, a small diversified operation. These are some pictures from that farm where we sold through a CSA, we sold through farmers markets, and we also had some livestock that we produced for our CSA members as well as the vegetables. So it was a very diversified little farm that we had here. We did some winter growing in high tunnels, and after I was done with the farming segment of my life, I moved on and worked for an energy company here in Pennsylvania, and we did energy audits and energy retrofits or energy upgrades and efficiency measures in residential homes and in commercial buildings. And we also did solar and wind design and install work with that company. And NCAT has a energy component to it where they provide energy resources to people, and they also have a sustainable agriculture resource side to them. So I kind of combined my background to come and work at NCAT in 2012. Um, you can see a picture of my straw bale house down here with solar. We were off grid for a number of years, but we still have solar, but we are grid tied now. So I can talk to you about alternative building. Anybody who's interested in that, kind of a sidebar, if you want to contact me later, you can talk to me about straw bale construction and other alternative efficient building methods. But today we're going to focus on energy efficiency on the farm. Let me just briefly tell you about NCAT. NCAT is a national nonprofit organization. We're based out in Butte, Montana, but we have specialists all over the country. And through our ATRA project, which is most farmers and ranchers know us through ATRA, that is a free service, information service in sustainable agriculture. So we provide resources and technical assistance to farmers, ranchers, and landowners across the country. You can contact us the old-fashioned way with the 800 number that you see on the screen, or you can email us at askanag@ncat.org, or go to our website, atra.ncat.org. We have over 300 publications that you can access there, all kinds of multimedia resources in the form of podcasts and video logs, and those are all available for free on every subject that you can think of in sustainable agriculture. So it's a free service, and you should take advantage of that if you have the time to look us up. So, and I'm going to be mentioning some resources from ATRA throughout the presentation, and I'll have them all collected in a few slides at the end, and I can share these slides with everyone so you don't have to like copy websites down and stuff as I mention them. So today we're talking about energy efficiency, and I just wanted to talk a little bit about some of the reasons why I focus on energy, farm energy. We work with a lot of smaller scale and mid-size farmers. They come to us for information, and they tend to have production systems that are lower in energy intensity, but there's still areas where we can find efficiencies and save them some costs. And that's one of the reasons why I focus on energy, is because we can identify areas for reducing expenses. So, margins are really tight in beginning farming and in farming in general. And if we can find some areas to save money, that's one reason to look at energy efficiencies. And as fuel prices and electric prices go up, that becomes more and more important. We can also help kind of focus our energies or our funds and resources on upgrades that could make the most difference to us. So as I walk through a self-assessment here in a little bit of a farm, you can see that you could prioritize the most crucial areas first, and then make the most impact. That's another reason why we're looking at things at energy on the farm. And you can also contribute to improved operational efficiency. A lot of the upgrades that I'm thinking in particular automation of greenhouses and control systems that actually help you improve energy efficiency can also help you operationally. They can reduce your labor and make your whole system a little more efficient. So that's another good reason to be looking at this. And from a philosophical standpoint, some of the farms I work with just want to reduce their energy use and their carbon emissions and their carbon footprint, basically. And that may or may not be a top priority for everybody on the call here. But I've often seen also the customers of the farms that I work with that have some of them do care about energy use and its the impact on carbon emissions. So some of the farms I work with will actually use it in their marketing that they're producing using alternative energy and using energy as efficiently as they can on their farm, and they advertise that to their customers, and some of them do care about that. So those are just a few of the reasons why. And what we want to cover today is basically farming systems and how they affect energy use on the farm. And then I'm going to walk through a self-assessment of a farm. So what you can do just on your own to self-assess the energy use on your farm and look a little bit of building design and how that can affect energy use in those buildings or structures for a long time to come. And then we'll look at a few alternative energy options like solar or wind and agri-solar. I'm going to introduce you to, if you don't already know about agri-solar, which is the co-location of solar electric production, solar panels, and agricultural activity on the same land at the same time. So we'll touch on that toward the end of the talk as well. And I can't really see the chat, so I'll rely on Amanda to if there's anything crucial in the chat, and there'll be time for questions, I think, at the end as well. So
Yeah, sorry to interrupt, but would you like me to ask you them as we go, or just hold off till the end and I can read them to you?
yeah, maybe as we go, so I can
Yeah,
kind of address things as they come up. That'd be
perfect.
fine. Yeah.
So we had a question from Annie asking, can we get technical assistance understanding funding priorities for these technologies?
Yes, we can definitely, if you get in touch with me or um, another specialist at NCAT, we can guide you through what's available. There's been with the recent funding freeze, it has affected things like REAP, which is Rural Energy for America, which was the kind of flagship assistance program from the USDA, at least, for alternative energy on farms and rural businesses. But that's kind of been frozen for the time being. We don't know the outcome, we don't know the direction that's going to go, whether that'll come back or not. But there are state incentives that we can guide you to as well. So yeah, get in touch with us with that. Okay, so there are two basic types of energy use on farms. There's the direct energy use that's actually going on the farm, appliances and equipment that's plugged in or using fuel on a day-to-day basis. That's the direct energy use, of course. And your energy use that's used mainly through inputs would be called indirect energy use, because a lot of the inputs that go into agricultural systems have a lot of embodied energy in them just to produce them and get them to the farm and then to apply them, So the type of production system that is used in any individual farm will dictate how much direct or indirect energy is being used in that particular operation. There we go. So just to step back, just to the bigger picture a little bit, energy, this is a pie chart of energy consumption in industrial sector, different industrial sector, the main industrial sectors in the United States: manufacturing, construction, mining, and agriculture. And you can see that agriculture is kind of using the least amount of energy on a national basis. If I was going to, look at this strategically and tackle energy use in this country, I think I would look at, because overall energy use in agriculture is kind of lower, doesn't mean there isn't still a lot of energy being used in the agricultural sector. And there are a lot of opportunities for saving energy, making things more efficient, and reducing costs on individual operations. So, how your production system uh, affects energy use, I would say more production systems that tend toward more human scale, meaning hand labor, hand cultivation, those types of human scale production systems are lower energy use, lower energy intensive, less consumption of energy most of the time. And also systems that tend towards using less inputs. They reduce both direct costs on the farm of applying those inputs, because it takes energy to do that in a lot of cases. And they're also reducing the embodied energy that's used to make those inputs. Um, Reduced tillage is one type of technique in a production system that can reduce energy usage. You have less passes in a field when you're reducing your tillage. So less energy, less fuel consumption is being used if you're on a tractor scale. And with livestock, grazing or managed grazing systems are probably one of the lower consumption production systems of energy, because you're taking the animals to their food source instead of, doing a lot of field work and transporting that food source to the animals that are more stationary. And you also have the other end where the nutrients that the cattle or livestock are producing are distributed without use of energy as well, if they're out on a managed grazing system, and you don't have to haul all that manure and spread it. So that's one of the least impactful from an energy standpoint. Managed grazing systems are one of the most energy efficient systems out there. And then relating to a production system, a lot of times when it's a smaller scale, local scale production system, they're using direct marketing and local distribution, which reduces energy use as well, compared to a lot of packing and transportation of product, either regionally or nationally, or sometimes internationally, for larger scale farming. So this is an example of where how reduced inputs, one example of reduced inputs. You can reduce your fertilizer, herbicides, and pesticides by using cover crops, crop rotations with mixed with legumes mixed into the rotations for nitrogen bars for some of your soil health and soil fertility, and also use integrated pest management and organic farming practices to reduce and along with that, like we mentioned, local markets are oftentimes used. I put Rodale Institute up here. It's a Pennsylvania institution that has a lot of really good resources on organic farming systems. ATRA, on my project, also has a lot of good resources on that, but Rodale has been kind of on the forefront of organic practices for a long time. Okay, so even if you are using a low impact or a very efficient, energy efficient production system, there's still areas where you can see improvement. And I use this as an example. Well, some of my examples in the talk today will be high tunnel and greenhouse focused, because I work with a lot of farmers that use high tunnels and greenhouses. But this is an example I use. Originally, high tunnels were supposed to be just a low cost, very simple structure with passive heating and passive ventilation, so there was no energy inputs into these except for the embodied energy in the plastic itself. but no direct inputs from the farm energy-wise. But farmers have stretched that definition now, and we're moving towards what you see more in the middle of this slide. What I just described is the left-hand picture on the slide, but in the middle of the slide, you see a propane heater's been added. Um, Horizontal airflow fans have been added. Ventilation fans in the end wall have been added. They have automated roll-up sides now, oftentimes two layers of plastic with a blower that's blowing air in between. So there are now added energy inputs into these systems, and it adds up. And now we can start looking at these appliances and looking at these energy using systems and try to make them more efficient. Here on the right-hand side is a kind of an extreme example of this. This is in New Mexico, a hydroponic system where they're pumping water for the plants. It's all closed, no natural ventilation, so all the ventilation is mechanical, all the cooling is mechanical, and there's a lot more energy inputs there. So I will say, just rule of thumb, the more energy that's being used on your farm, the more likely you are to be able to find areas to save energy use. So dairy farms, for instance, are a very high energy intensive system. So usually if we go onto a dairy farm, we're able to find a lot of efficiencies. But that doesn't mean that we can't go into a high tunnel like this or a smaller diversified vegetable operation or something like that and find ways to save on energy as well. I always mention the Natural Resource Conservation Service, NRCS. They have a high tunnel initiatives, which I mentioned to my high tunnel growers, but they also have a on-farm energy initiative where they can help pay for an energy audit on your farm. And then based on the audit, they'll help pay for energy upgrades or retrofits for your farm. Now, they've also been affected, I think, by the federal freeze. So we don't know what direction that's going exactly. But it does pay still to introduce yourself to your local NRCS office and find out who your person on the ground is there and make your farm known to them to see if they have anything that they can help you with. Okay, so short of a professional energy audit coming onto the farm, they're hard to find. First of all, they're expensive. They can be expensive. There's a lot you can do yourself. And I walk through this, what I call an energy self-assessment of your farm. This can be done for all your farm buildings and your farm enterprise, but also your residential in your residential life. And a lot of times in the farms we work with, that's a mixture. The residential and energy used on the farm and energy used in the residence are overlapped to some degree. So this is a farm-wide approach that you can take to find areas to save energy and save money by making things more efficient. And it consists of these four steps. You can basically review your electric bill and your fuel bill and glean some information off of that. And we'll go through the types of information you can pull from that. And then go through an actual walkthrough and list all of your equipment that uses energy. List the wattage of electrical appliances and things that are using fuel. You list how much fuel that's used in the past. So you have an idea of what you're spending or what usage is and consumption is with different appliances and different equipment on the farm. Then, lastly, not lastly, but third, you go through any structure that's heated or cooled and look for air leaks and insulation values. Oftentimes, they can be upgraded and save a substantial amount in fuel costs and cooling costs as well. And then after you've gone through and hit some of the major efficiencies that you can do with your other equipment, then you can think about capturing, energy resources that are available on your farm, like sun and wind through solar and wind. So that usually is, I say, make things as efficient as you can first, use as little energy as possible, and then look at your alternative energies as a way to deal with some or all of the rest of your energy needs on the farm. So let's walk through and look at I think it's a bill here next. Yes, this is an example of a regular bill, and there's a few things you can glean from your energy bill. Of course, this is an electric bill. You also have energy bills related to fuel, but they're a little more straightforward. So I spend more time talking about electric bills. Um, you want to look at your annual highs and lows. They call it like base load analysis. So you know basically what you're using all the time. But when you see a spike in your usage, let's see if I can use a laser pointer here. If you can see a spike in your usage on this graph here, which they include on all of these bills, you want to be able to ground truth that with what's going on the farm. You should be able to think, well, okay, that's the time of year when my walk-in cooler kicks in. It's running a lot more. That's the time of year when I'm using more air conditioning, or it may be when we've started the greenhouse up and we're using a lot more energy in there. But if you can't kind of think of one of the major things that's causing a spike like you see here, then you need to do a little more digging to see where that consumption is actually coming from. So that's one way to use this. The other way would be to compare for previous bills. So you look at previous months and previous years through your bills to see if if you're doing energy upgrades, if they're actually working and if you're actually consuming less energy. So that's a valuable thing to keep a history of. The other thing you can glean is your rate that you're being charged per kilowatt hour. And you can also talk to your energy company and find what kind of rate structure you're being charged. And we'll talk about that in a few more slides here. Um, but you can also look at your kilowatt hour usage and what you've been charged and figure out what I call the real cost per kilowatt hour that you're paying. So if I go over here to the second part of the bill and you see this circled area here, they're telling us in this example that you're paying 8 cents a kilowatt hour. But we know in actuality, because we have the current usage and we have the current charges, we know you're actually paying, using this little formula down here, you're paying 20 cents a kilowatt hour. That's because of all these extra charges that go on to your bill. So you might be using the price to compare that energy companies say they're charging you for per kilowatt hour, but you should be able to figure out using current charges and current usage that you're actually paying probably a little bit more than that or quite a bit more than that. And this would be the number down here, this 20 cents a kilowatt hour that you would use to figure out what equipment is costing you to run when we do our energy assessment a little bit later. Okay, the other thing on here would be the rate. Said you could figure out the rate that's residential. So it may pay for you to talk to your utility company, your electric company, to see what their commercial rates are. Oftentimes, commercial rates are lower than residential rates. And it may pay to separate out your farm energy bill with a separate meter and pay commercial rates on that. If those rates are low enough, it might be worthwhile doing that to save money over the long term. Okay, so those are the few things you can glean from your bill. Um, I was going to talk about usage charges and rate structures. For fuel, it's very straightforward. They're usually a fixed rate structure. You get a certain amount of fuel, and it's a certain price per gallon or per therm, depending on what fuel you're working with. But those, of course, those rates can fluctuate throughout the year, but it's always a fixed rate structure when you actually buy the fuel. You're going to pay a certain amount per unit of the fuel. With electricity, it can be a little bit more complicated. They can have a fixed rate structure, which is the same rate for all your kilowatt hours used. Or it could be a tiered rate structure is another popular structure. And what that is the more kilowatt hours you use, when you hit a certain threshold, the price for the next uh, amount of kilowatt hours that you use goes up. So it would pay to know where those thresholds are, whether you're on a tiered rate and what those thresholds are so you can kind of stop your usage before you go over a certain threshold and pay more for the rest of the kilowatt hours that you use that month. The other common rate structure with utility companies is time of use rate. So this means that during high use periods for electricity, everybody's coming home from work, so to speak, for example, and they're turning on their electric appliances, they're cooking supper, having taking a shower. A lot of electric use is going on, and they charge more for those time periods. So it pays to know if you're on that rate structure and to avoid using energy during those times or consuming electric in those times so you can avoid those higher rates. A lot of times, timers and controllers can be used to help you avoid those time periods that you're paying a time of use rate.
Well, so we had a question from Monica asking, what's the best way to understand peak hour usage and how that ties into farming usage? Are there any do's or don'ts you can help us with?
Well, I think there's a lot of processes on the farm that you have to do no matter what time it is. But there are certain things, depending on what your operation is. I don't know what your farming operation is like. But for instance, irrigating is one of those things that can be done. I mean, there are better times to irrigate than others. There's no doubt about it, ability there. So you don't have to be pumping water during your peak hours, you know. Um, there's a couple of it on per case basis depending on what your operation is. But if you know what your peak hours are, there's oftentimes there are ways for you to avoid using energy during those times. Um, Timers for, I'm going to talk about this a little later, but timers for heaters like stock tank heaters that keep things from icing over, uh, timers for engine block heaters, those don't have to be on all the time. So there are certain appliances that you can run at just off-peak hours, and it's plenty of time for to do the job, but you don't have to pay those higher rates. So I hope that was helpful. I could talk more individually about that if when I, one-on-one, you could email me and I can learn a little more about your operation and maybe give more specific suggestions for that.
Thank you for
But
answering. Appreciate it.
sure. But try to work with your supplier. You could shop for your best rate, of course, and you can also check with your utility company for rebates and incentives that they may have. Some states require utility companies to put a certain amount of money towards efficiencies, and they do that sometimes through incentives to their customers. So it pays to check and see if they would help pay for more efficient motors or controllers or anything at all that might help your farm operation save some energy. Okay, then the next step would be an actual walkthrough assessment where you're going through and list all of your appliances, all of your equipment, anything that uses energy. And this can be a little bit time consuming, but it does pay to capture everything and try to get an estimate on your electric usage appliances and equipment of how many watts they're using and how much they run, like how many hours they run in a day, a week, a month, a year. And that's mainly an estimate on your part, but it can get you somewhat close to how much that appliance or that piece of equipment is using, how much energy it's using. Um, you want to start with systems that you've identified with your bill analysis. If you came away from your bill saying, oh, it looks like my cooler when it kicks on is really using a lot of energy, that might be a good one to start with then, or your on-farm store, if you have a little market store for your farm. Boy, when I get that going in the spring, my energy bill goes through the roof. Maybe I need to look at the cooling units and the freezers in there and maybe the air conditioner in there. That might be a good place to start. So, use your bill analysis to inform you on where you might have the most impact starting to look at your actual equipment on the ground. This is just direct energy use on the farm. Some of the things you'd be looking at depending on what type of farm you have. A diversified vegetable operation. They have greenhouses or seedling houses and high tunnels. And in there, you're looking at all your ventilation and horizontal airflow fans, any heating or cooling that's going on in there, heat mats, germination chambers, watering system, those types of things. Your tractors and equipment, irrigation system, your wash pack station can be sometimes high energy, depending on how you have it set up. And then your walk-in cooler, sometimes they can be improved quite a bit. And then if you have an on-farm market, like I was just mentioning, and then your lighting is usually going to be pretty efficient already. But if you're an operation that has a lot of lighting involved, indoor growing, for instance, or something like that, it would pay to look at your lighting and how much that's costing you. For small grains, you're looking mainly at storage and drying. Those are the high, and the tractor or field work. Those are the high energy users there. Some transport as well. And then pastured livestock, like I said, is the lowest impact, but you still may have, your watering system and tractors and hauling. And if you're direct marketing, there could be freezers involved. And also, like I said, dairies are all of the above, plus a lot of water heating on top of that. So these are some of the direct energy uses that you'd be looking at in your walkthrough assessment, depending on your operation. If you're doing processing or value added, like cheese making or something like that, then you're going to have a higher amount of energy use in those processes for sure. This happens to be a picture of a dairy with a plate chiller and some of the other equipment that's used on the dairy farm. We do have I don't think that any of you are going into the dairy business, but we do have a dairy farm energy efficiency publication that you can access that I have a link to here, and I have it in our resource slides as well. Okay, so then once you have your equipment listed, this would be the operation for start with the bigger stuff, but you get an estimation of your watts. Let me get a pointer here again. Get an estimation of how many watts that uses, or the rated watts, which would be on the nameplate or the boilerplate of the appliance, and how many hours it's used. And you divide that by 1,000 and you get to your kilowatt hours. And you don't have to memorize this. You could, once you're to the stage where you're actually doing this on some of your appliances, you could talk to me and I can walk you through this for sure. But it's very simple. You get, for example, this ventilation fan is 1,118 watts. It runs 2,000 hours, for example, and you divide that by 1,000 and we end up with 2,236 kilowatt hours. If we multiply that by our 20 cents real rate that we figured out earlier, this is costing $447 to run for those 2,000 hours. So it doesn't sound like a lot, but in some greenhouses, you may have 4 of these going. They may run a lot longer than 2,000 hours, and it ends up being a couple $1,000 pretty quickly. If you can't find the watt rating on an appliance and you can only find horsepower, you can use this conversion to watts. And if you can only find volts and amps, you can just multiply them and get watts. So you're always trying to get to how many watts something is using, and then you can go through this process and find out what it's costing you to run, how much energy it's using, and what it costs to run that appliance. This is a typical nameplate. I don't expect you to be able to read it. It's just for an example. This happens to be on the back of a heater for a propane heater for a high tunnel. And there's a lot of things you can glean from the nameplates on these appliances. For instance, heaters, you get to know the output and input BTUs. They're listed on the back, and from that you can tell the thermal efficiency of the heater. You divide output BTUs by input BTUs and get the thermal efficiency. Then you can compare heater efficiency. Um, you also, on fans and ventilation appliances, you'll get cubic feet per minute, how many cubic feet of air they move per minute. You can also, and you can use that to figure out, along with the wattage of the fan, how efficient that fan is. You get horsepower readings on electric motors. Oftentimes you'll get volts and amps, and you can find watts, like I said earlier, by multiplying volts times amps. This math here is the same equation that I used in the previous. It's just for the blower on this heater unit. And it costs $177 to run this heater in electric because there's a blower on this. It also costs the propane, of course, that it uses, but in electricity, it's $177. This resource I have here for you is how to read nameplates off of agricultural equipment. It gives you a lot of good tips and tricks on how to do that, what to glean off of them, and what it means. So I have that included in the resource list as well.
Chris, sorry to interrupt you again. We had another question from Monica asking about that data plate is when it's clean and operating correctly, correct? Meaning dirty equipment costs more to operate. Is that fair to say?
That's very fair to say. It's true with heaters. It's true with motors. Any electronic motor on a fan, for instance, if that has a layer of dust and soot on it, it's insulating it and it runs hotter. And electronic equipment does not like to run hot. It runs less efficiently. So thank you for bringing that up. I do mention that later in the talk about keeping things clean and well maintained in order to keep them running as efficiently as you can. So this is a watt meter. It's an inexpensive tool that if you're serious about, learning how much things are costing you and how much consumption electric appliances are having, you can buy one of these fairly inexpensively and plug it right into the wall, plug your appliance in, and it tells you exactly the amount of wattage being used. And you can program in your cost per kilowatt hour, and it'll tell you what it costs to run that appliance. So it takes the guesswork out. And the longer you keep an appliance plugged into this, the more accurate it is. These are called kilowatts, and you can buy them anywhere on the a lot of places on the internet will sell them. So ventilation fans, for instance, I'll talk about, but this can apply to any fan or anything moving air on a farm anywhere. They should be sized properly, not oversized, so that you're using more electricity than you need. For instance, for ventilation fans for a greenhouse, in the warm season, you only need 8. In the warm season, you need 8 CFM per cubic foot. In the cool season, you need 2. So a farm that's heavily relying on mechanical ventilation, I would suggest they have a two-speed fan with a two-stage digital thermostat to control, so they're not always on 8 CFM per cubic foot when they don't need it. So there's things like that you can definitely take advantage of. The ventilation efficiency ratio there of a fan is the cubic feet per minute that it can move divided by the wattage rating on the fan. And if you look for something 15 or higher, ventilation efficiency ratio of 15 or higher, it's considered a fairly efficient fan. The higher the number, the higher efficiency. There's the Bioenvironmental and Structural Systems Lab at University of Illinois. There's a database there of all agricultural fans and their efficiency ratios. So if you're looking for new fans, that's the place to go. I have a link to it here that you can link to. And keep them clean here at the bottom, like we were just saying, keep them clean and well maintained. I recommend a um, small shop vac that you can carry around with you and a brush of some sort to clean motors off, clean the shutters off and the fan blades off. Anywhere that dust collects, you can go through once or twice a year. I know there's a lot of work on a farm to do to keep you busy, but um, this is something that can save you money over time if you keep these clean at least once a year, go through and give them a really good cleaning. And then there's the option of natural ventilation in farm buildings. This example, of course, is a high tunnel, but for natural ventilation to work well in a farm structure, I've seen it in livestock housing and in greenhouses and high tunnels. You need a lot of open space near the top of the structure, like these large gable vents, or better yet, this big open vent, ridge vent, and you need a lot of open structure toward the bottom of the structure. So in order for this to work well, you need those big open areas. The rule of thumb is um, 15% of the square footage area of the building that you're trying to ventilate, you have to have 15% of that square footage open toward the bottom of the structure and 15% of that floor area open toward the top in square footage, if you understand me. So it takes quite a bit of space to have natural ventilation work well, but it can. And with just a small 1 or 2 mile an hour breeze outside, you can keep indoor temperatures very close to outdoor temperatures and shut your fans off altogether. This is the same, very similar, horizontal airflow fans. I don't have to go through all of this. I would just say that keeping them maintained and cleaned is important as well. And I will mention with fans, the larger the diameter blade and the lower the horsepower, you're going to have much more efficiency involved in a fan. So if you're looking at fans, the ones with large blades and smaller horsepower motors tend to be more efficient. So when it comes to heaters, this is a propane heater for a high tunnel. They need to be sized properly as well. If they're too small, you're going to be you're not going to have enough heating going on. It's going to be running constantly to try to get the BTUs up, enough BTUs out to heat the structure. But if it's too big, then it tends to cycle on and off frequently. And in order to reach maximum efficiency in running, they need to heat up first. So if you have a lot of cycling, not only is it not good for the appliance, but it also never reaches or spends a lot less time running at full efficiency. So it pays to size your heaters properly. Here, for greenhouse purposes, this is a heater sizing calculator. Um, that works really well that I have in the resource lists as well. Maintenance of these is important. Inspect them for damage when you get things up and running in every year. Inspect the vent pipe, especially for damage or dents and any air blockage that's happening. I've seen birds' nests on top of the vent pipe blocking airflow. That can be dangerous, and it also makes the unit run much less efficiently. Soot removal can really be important in the vent pipe and in the heat exchanger within the structure, within the heater itself in here. If you can get the layers of soot off of there, it can help a lot. An 1/8 inch layer of soot can increase fuel use by 10%. So it does pay to keep these clean. If you have quite a few of them on the farm, you can call an HVAC person and have them come maintenance once a year and clean everything up for you. Otherwise, it is something that can be done yourself as well. This is a picture of a high efficiency heater, propane heater. It's got a plastic vent. They're called closed combustion heaters, and they produce so little heat in the flue gases that they can vent with plastic pipe. Whereas regular heaters are around 80 to 85% efficiency, these are about 90 to 95% efficiency, thermal efficiency. So you're going to gain 10% in, or save 10% in fuel costs basically by switching to a high efficiency heater. Now you have to gauge that against what you're paying in fuel. And if you have a higher fuel bill, say something like $3,000 a year to heat a greenhouse or something like that, you could justify, I think, switching to a high efficiency heater. They cost uh, approximately $1,000 more, $1,500 more. But especially if you're going to replace an old heater that's not working well, you could justify moving to a high efficiency heater because it's going to pay itself off in 3 to 4 years, and then you'll have that improved efficiency for the life of the heater. Controls can be very beneficial, very useful in energy efficiency. I give the example of this mechanical control thermostat here in the middle. Mechanical thermostats can be as much as 5 to 8 degrees off of the set point for the thermostat. So that means in a heating situation, you may be overheating the structure 5 to 8 degrees before the unit shuts off. That every extra degree that you heat a greenhouse, for instance, or a high tunnel, you're spending another 3% in fuel costs. So your fuel costs could be upwards of 15 to 20% higher with a mechanical thermostat as opposed to a electronic thermostat or a digital thermostat, I'm sorry. Um, and the digital thermostat has other advantages as far as a lot of them are able to run many units, several units at once, and can keep, sometimes there's records can be kept for highs and lows in the greenhouse and those types of things. So it sometimes would pay, or oftentimes pays, to move to a digital thermostat. Uh, there's also two-stage thermostats that can run a variable speed fan and save you energy that way. So there's a lot of reasons why you might move to a better thermostat than these mechanical thermostats here. So start with the low. You can start with low-hanging fruit. I have a list here of different things that are fairly easy that you can do right off the bat. Lighting is probably already taken care of. There aren't many lighting. There's not much lighting out there that isn't compact fluorescent or LED at this point. But if you have, like I said, a lot of light in your operation, a lot of lighting, it would pay to look at that. Timers, we talked about a little bit. I suggest timers all the time on stock tanks that are like stock tank de-icers. They don't have to run 24/7. Engine block heaters, they don't have to run 24/7. Um, Timers for lighting, if you have a lot of light in your operation. Pay attention to leaks in your irrigation systems. They can add up, and all that water has to be pumped. So um, leaks can be a big issue. Air leaks it can also be an issue when you're talking about heating and cooling. So try to seal your structures up. And maintenance, we talked about cleaning and talked about controllers and thermostats in the last slide, but maintenance is important. This is a compressor motor underneath a refrigerator or a freezer, and that's running probably 20% less efficient because of that being all clogged up under there. So get a brush, a refrigerator cleaning brush. You can buy them in the local hardware store and get them cleaned off with your shop vac and brush. So I mentioned irrigation. You can improve, most irrigation systems can be improved when it comes to efficiency. I always quote the statistic that 1 drop of water per If you have a leak in an irrigation system, 1 drop per second adds up to about 50 gallons a week in water, extra water being pumped. And most irrigation systems I've looked at have a lot of drops per second coming out of them. So tighten up those connections for sure, and use a lot of drip irrigation or micro irrigation where you can. That saves on water usage, and then as a result, the amount of water you have to pump, so it saves on energy. And don't overwater. Try to monitor your soil moisture. Come up with a system so you're not overwatering your plants. Um, that can save you quite a bit of water as well. There's a great resource that we have at ATRA called Energy Saving Tips for Irrigators. That's an ATRA publication that I have a link to here in the resource list that has a lot of good information in about making your irrigation systems a lot more efficient. So I was talking about air leaks a little earlier, and any structure you're heating or cooling, whether it's a high tunnel, a greenhouse, a an office area, or a on-farm farm market building, whatever it is, it pays to look at the air infiltration. Any structure has what's called the stack effect going on, where warm air leaves the top of the building and cold air comes in the bottom. So any visible air leaks that you can seal up can help from a heating standpoint. And insulating to the proper levels can also help from a heating and a cooling standpoint. Um, so it pays to look at these structures and seal them up, tighten them up. Here's a good example of a very tightly built greenhouse. This is a heated greenhouse structure on the left-hand side, and they're very tight to the foundation here. The end walls are polycarbonate, which have a little bit of an R value to them, an insulative value. Polycarbonate panels, very tight seams around here, and the door is installed properly. All of those things add up to a tight structure. Shutters are very hard to make tight, but you can make sure they're not bent and that they're seating well on each other so that there's not a massive amount of air leaking there. This is a high tunnel on this side, and it has a roll lock on the bottom. So when this side rolls down, it locks into place under this J channel and creates kind of an air seal there, or a tight seal. So there are things you can do to tighten up your structures, tighten up the buildings, and that matters a great deal when there's heating involved. So you can also think about once you've gone through all of your assessment of your appliances and equipment that use energy, if you're planning on building anything new on in your operation, any new buildings or renovations, you can start thinking about designing for efficiency. And that is highlighted with something like this. This is a shed that I designed for my farm. It's just a garage to fix equipment in and store some equipment in. But I used a passive solar design on it, which includes southern facing windows, or glazing as they call them, and not too many windows, not too much, not too little. And there's a formula for that that you can access in this resource here I have at the bottom of this page, is the Sustainable by Design. They have tools in there for calculating the amount of glazing in passive solar design, the amount of overhang of your roof, because that's very important to keep out the summer sun, to keep it cooler in the summer, let the sun in the winter time, depending on the angle of the sun. That overhang is very important. And also having some thermal mass inside the structure can help retain some of the heat gain from a sunny day that takes place. So the structure should be air sealed very well and insulated well as well. The other advantage of building with a kind of efficiency in mind is you can be solar ready. And what I mean by that is this roof on this structure is facing south. It's at a good pitch for solar panels. If I ever want to put solar panels on there, it's ready to go. It's good for a roof mount solar panel system. So it pays to think a little bit ahead when you're designing a new structure, because you can build in those efficiencies for the life of the structure. Um, some alternative systems, and this is just a passive solar design as well. This is a seedling house on a farm in New Hampshire, and it's a classic passive solar design where it's twice the width, twice the length as it is wide, twice as long as it is wide, and you've got this very steep pitch to the front glazing here, and they're using a lot of insulation in the back wall and then the side walls, and it's a very tight structure. So they have very little extra heat added to the structure to grow their seedlings for their farm. Um, it's just where it's an example of where it pays off to put a little extra thought into the design of a structure, so you're not adding a lot of energy inputs through the life of the structure. Anytime, anytime you're um, thinking about solar, it pays to know where the shade is going to be on your property. And I'm not going to explain this in depth, but this UNH fact sheet explains how you would graph out a sun chart um, to find out exactly where the shade is on any part of your property, and it tells you when it will be shaded any time of the year and any time of the day. So it's very useful when you're thinking about passive solar design or um, solar electric install. So I'm going to give you these resources from UNH, and this second resource here is where you can print out an actual sun chart like you see here. And in a half hour, you can learn how to chart this graph. I charted this on my property. Anything below this line that I'm pointing to is shaded. So I know, for instance, at 9 a.m. on March 20th, which is this intersection, I have full sun at the spot that I made this chart for on my property. Whereas at 10 a.m. on January 22nd, I have shade there. So this can be a really handy and useful tool. And it's complicated looking, but it's not hard to learn how to do. So then once you have gone through your assessment and you've started some energy efficiency upgrades, you've gone to some higher efficiency fans, maybe you've kept your equipment clean, you've put some timers in place, some good thermostats to control things, and you've done a lot of things to make things efficient. Then I think it would be time, if you still wanted to take care of some of the rest of your energy needs, to start looking at alternative energy systems. Solar and wind, for instance, would be two examples. And we have a resource here at ATRA called Renewable Energy Opportunities on the Farm. It's a good publication to introduce you to the opportunities in renewable energy. I would say that solar is a very viable option, I would say. It even works up here in the cloudy northeastern part of the country. Um, but there's other parts of the country where it's much more, there'd be a much faster payback, of course, where you have more sun. This system on the left-hand side is solar thermal. So these are flat plate collectors heating water or heating a liquid inside the collectors, and that liquid then is going into this high tunnel, and it's run through tubes underneath the beds to do subterranean heating or root zone heating in this structure. And the second one is a roof-mounted solar photovoltaic system on a farm here not far from me. where they put it on their greenhouse. They have this passive solar greenhouse, and they decided to use the roof space for a fairly large solar system that's taking care of most of the energy needs of their farm. They do all their processing in this building as well for their vegetables, and she's got a flower farm there, and they do the flower, put the flowers together in there, and the electric is basically taken care of by this system. You can also do a ground mount solar voltaic system. Roof mount or ground mount can work. Um, there are some state incentives for alternative energy systems that I'll point you to in that direction in a minute. But it's also useful, solar is also useful for remote energy needs. This is a livestock watering system that I put in on my farm to handle about 12 head of beef cattle. And the system's pretty simple. It's 260-watt panels, and a pump controller sits down underneath the panels. We have a submersible pump. You can't really see it, but there's a pond down here below these weeds, and there's a submersible pump in there that pumps upwards of 2,500 gallons a day on a good sunny day. And we have up on top of the hill here a 1,500-gallon storage tank that then gravity feeds back down to the stock tanks in the pasture. So these can be very effective systems for remote locations where you can't easily get electricity to pump water. Um, and solar is very good for those types of situations. We have a ATRA publication, Solar Powered Livestock Watering Systems, that I'll include also on the resources list. And wind power is something to consider as well. Most people who think they've got a really good site for wind, for a wind turbine, don't have a good site for a wind turbine. If you think there's a steady breeze all the time, that might be so, but most of these smaller scale wind turbines need um, they need a 10 to 12 mile an hour wind, steady wind, before they even start producing electricity. So I would recommend putting up an anemometer to measure the wind speeds on your property for, as long as you can wait to see the results for that. Up to a year would be a good amount of information to have before calling it a really good wind site. But that being said, if you do have the right site, they are long lasting with maintenance. They need some maintenance once in a while. Of course, they're not sun dependent; they are wind dependent. But they can operate in the day or at night if you have the wind. So in that way, they have a slight advantage. They're good for remote applications, just like solar. And they have a very favorable energy payback ratio, which is it's the ratio of the amount of energy that they produce over the life of the system, compared to the amount of energy that it took to produce the wind turbine and um, and install it. So that's a positive. And there are some incentives for wind as well out there, state by state. And you can look on this website, desireusa.org is a good website to learn about all of the state incentives for alternative energies. So you can actually look up your state and see all of the incentives that are available within your state for alternative energy systems. There's no standard wind speed rating on them. They're not well regulated. A lot of the wind turbine companies kind of will make claims that might not be quite true. They are very location specific. There is a noise factor if it's going to be close to your residence or someone else's residence. And of course, you're going to see it just like solar. You're going to see it, but it's sticking up pretty high, and they can cost a little bit up front for sure. Uh, Small scale wind energy is another publication that we have from ATRA, and you can go to that publication to find out more about small scale wind energy. There's two types, of course, electric production, and there's still a company or two producing these water pumping mechanical wind wind towers. So they're still an option as well. So I wanted to spend the last part of our talk together here talking about agri-solar. NCAT, my organization, has developed what's called the Agri-Solar Clearinghouse, which is a clearinghouse of information on the topic of agri-solar. And what agri-solar is a co-location of solar and agricultural operations on the same land happening at the same time. And when I say solar, it's solar photovoltaics, it's electric production solar. It's also known as co-location or agrivoltaics or dual use solar. Those are other names that you'll hear it called under. But if you're interested in this topic, you can go to our agrisolarclearinghouse.org, which is a website devoted entirely to agrisolar. We have an information library there with 500 different articles and publications on different, they're all curated, so you can search by topic very readily. There's a media hub there with videos and other media resources. There's also a connections page and a forum that you can connect with other people who are interested in this through. And over the past few years, we've provided technical assistance, and we also have a financial incentives atlas on there that draws a lot from the Desire USA resource that I gave you in one of the previous slides there. But there's also, we try to keep that incentives atlas up to date. This resource on the bottom here is called Best Practices in Agri-Solar. This was kind of the culmination of the 3-year project, and it's a 100-page document on all the best practices in agri-solar. So it's a very interesting chapter by chapter read of how agrivoltaics works and the types of agrivoltaics that are happening in this country right now. We promote through the AgriSolar Clearinghouse, we promote this type of use of AgriSolar. One, uses that don't take prime agricultural land out of production. We like to see borderlands and roadways, hedgerows, and more degraded lands and lands that aren't really well suited for prime agricultural production. We like to see them focused on first for solar development. And that's what we kind of promote through the AgriSolar Clearinghouse. And then when possible, convert single-use solar arrays, these larger solar developments that are on good farmland, try to convert them to some type of agri-solar operation, whether it's adding pollinator strips or an apiary, beekeepers utilizing the ground, or high-value crops being planted under them, or being used for grazing. That's one of the most popular forms of agrivoltaics, is grazing the land underneath the panels with sheep. But we don't think it should reduce any pollinator spaces by installing solar, and we don't want to see any ecosystem services of the land that's being used diminished in any way by the install of the solar. And we know these things are happening. Big solar development is happening across the country, and it happens to be very easy to install those, very attractive to install those larger solar systems on nice farmland, because that's the open space that's available and it's easiest. But what we're trying to promote is a different use of that land. Grazing, like I said, is one of the most simple ways to convert a standard install solar system into an agrivoltaic system, meaning adding agriculture to it. Because sheep, which are very well suited for it, they can graze underneath the panels without damaging them, and they're perfect size, And oftentimes it's a win-win situation because the whoever's owns the solar development is paying less to the farmer than they would for a land management company or a landscaper to come in and actually keep the grasses down underneath the panels. So there is an organization called American Solar Grazing Association. They are a great resource for solar grazing. I have their website here, solargrazing.org. And this, I think, is actually a really good opportunity for new and beginning farmers who want to get into grazing but don't have access to land to try to promote their business to solar developments that need land management underneath the panels. And we've seen grazers that rotate their sheep from system to system in any given region. They'll transport them around, let them at one spot for a while and another spot for a while. And sometimes they have to haul water to them for water access, but it's still oftentimes worth it for the grazer to do that work. But if you want to learn more about this, you can go to our agrisolarclearinghouse.org. You can also go to solargrazing.org for American Solar Grazing Association and learn a little bit more about this about this process. So that's just a few other resources I have for you. This is a self-guided tutorial on farm energy on all of these different topics. So you can pick each topic individually and at your own pace, you can guide yourself through this self-guided farm energy tutorial. And you can see that there's farm building efficiency, outdoor lighting, irrigation efficiency, solar electric, small scale wind, and biodiesel is covered. And you can reach that through this link here on our ATRA website, which I also have in our resource slides, which are here and here. And I can make these available through Amanda to all of you. But that's about all I have for you this evening. I really thank you for your attention, and I'll try to answer any questions that you might have. Because I think we have a little bit of time. But if you have additional questions, you can email me directly, chrisl@ncat.org. If you think of something afterwards that you forgot to ask, or want just more information about ATRA or NCAT or AgriSolar Clearinghouse, just send me an email.
Thank you so much, Chris. That was amazing.
Mhm.
That was an awesome amount of knowledge and wealth. So there's a few questions in the chat I'll ask you, and then I'll open it up to the floor. And I do want to respect Chris's time, so we have about 10 minutes left before we got to end this meeting. So for the chat, Annie asks, any rain harvesting combined with energy efficiency?
Well, certainly on a when you think in terms of pumping water and the energy involved there, I think rain harvesting can definitely be beneficial. I've set up rain harvesting systems on high tunnels before by putting plastic gutters along the hip boards and collecting water that way into a water tank. And then I just had I used a small AC pump to feed that into my drip tape inside the high tunnel. And I collected quite a bit of water here in the Northeast. I collected a lot of water for that system. I think those systems work really well with a small a small DC pump with a solar panel and battery as well. That can be a good use for solar to pump that water in through a filter and into your drip tape, and you're saving any water pumping costs associated with an electric water pump at that point.
Awesome, thank you. And then Monica asks, what's the single largest energy efficient equipment or material upgrade / game changer you have seen in the farming space that you are really excited about?
That's a big one. It's a big question. I I would say for me and the types of farms I work with, what's been really interesting and exciting to me is how efficient you can make a high tunnel or a greenhouse with very simple upgrades. If you pay attention to the type of plastic you're using, for instance, if you have the infrared protected plastic, you can save 20% on fuel costs because it holds in heat. If you have a double layer of plastic with the infrared and the inside, then you save even more on fuel costs. Um, if you're putting polycarbonate on the outer sidewalls with an R1.5 value, and you have two layers of blown-in plastic with an R1.5, you can basically insulate the entire greenhouse very, very simply. So those kind of upgrades excite me. I wouldn't say they're kind of game changers in the overall agricultural picture. Um, but I think that the to me, the idea of seeing a lot of small farms on a human scale come to life could be a game changer um, for local food systems and for energy, for that matter. If we could get a little further away from the huge commodity agricultural production, which is what is using the energy in the agricultural sector, and focus on local food systems and human scale food systems, that to me would be a really exciting change.
Excellent response. That was awesome. We have another question. Do you have any knowledge of solar powered moisture collection systems in wide use?
I do not have a lot of knowledge about those systems. I know I've seen a while ago, I've seen examples of like distilling water in arid climates with some solar power involved. I don't remember exactly how they were even set up, so I'm not the person to comment on those systems very eloquently at all. I'm sorry.
All right, we have another question. Any tax credits related to these improvements a farm can use?
Well, there are yes, there was a tax credit. There was a 30% tax credit for, I think, on the main thing that I'm talking about is the REAP program. That was a great incentive program. Um, that was a 50% tax credit from that program on all alternative energy systems and energy efficiency upgrades on farms and rural businesses. Again, that one was recently frozen, I think. So we don't know what the life of that REAP program is going to be. I think your best bet for tax incentives would be on a state by state basis with that desire.usa.org website. Um, we have uh, we have states around us here, like New Jersey and New York, that have state tax incentives that enable people to install um, or give people a payback in the form of a tax incentive on alternative energy systems. And you may have the same in your state if you go to that desire.usa.org site. That would be the place to check for that.